Hello, Mario. Finding the area under a curve. A look at trapeziums, the trapezoidal rule, and Simpson's rule. A trapezium. What is a trapezium? Well, it's a quadrilateral with one pair of parallel sides, minimum. So we can sort of look at a square, and that's a parallelogram. That's a trapezium. Uh, a parallelogram is a trapezium with two sides, two sets of parallel sides. So this is, I guess, what I would call the classic trapezium. That's it upside down. Here's our two our parallel sides, and here and here. This is the height. So we need to know the distance between the parallel sides to work out the area, as we'll see in the next slide. So, yep, here's your classic there. So to find the area of a trapezium, add the parallel sides, divide by 2, and multiply by the distance between the parallel sides. So here you can say you've got 4 plus 8, your parallel sides, add them together, 12, and divide by 2, 6, and then multiply by the distance between them, the height, 3 sixes are 18. And there you go. So, yeah, pretty straightforward, really. That gives you the area of the trapezium in centimeters squared in this case. So, yeah. Alrighty. Okay, so using the trapezoidal rule. So if we look at the green area here and we just imagine a line between there, N and O, we can see that there wouldn't be a very good approximation of the area of that sort of shape there with the what we call an irregular boundary. It might be a river or a stream or something like that. However, if we cut it up into a number of strips and then treat each of those strips as a parallelogram, we'll get a slightly more accurate approximation of the area. Approximation is a key word in this particular video. So yeah, and the more strips we break it into, the more accurate the area is. Until we sort of get into the concept of calculus, where we break it into an infinite number of strips and get a pretty well the most accurate area we can, because it's the exact area. But anyway, so if we look at this here and we say look at the trapeziums, we'd have one trapezium here, which would have this first side, and then there, and then we'd use the second and the third, and that would get used in those two trapeziums, and then so on until you get through to the last one, and you'd see that the first and the last sides would only be used once, and all the other sides would be used twice. So we can put this into a bit of a formula. And this is where we take the distance divided by 2. D is the distance between the parallel sides. And we take the first parallel side and the last, y0 and y8. So we're starting at 0 going through to 8. So that's 9 in all. And then we just go 2 times the ones in the middle. 1, 2, 3, 4, 5, 6, and 7. So there's 7 of those plus 2 is 9. And then we get a general formula. Note that n, or n is integer values starting from positive integer values, including 0. So 0 and n, and then we put them in there, and well, we get an area, which is really good. Now, there is a mathematical way of writing this, and it's used this what we call this definite integral here. The definite integral between b and a, f of x dx equals a half. H is, well, it's the distance between the distance between them effectively, but it's got a formula there. It's b minus a divided by n. Okay, so yeah, that's all well and good. And yeah, and y to the r equals f of x to the r is another sort of way of, they're the same thing. So we can sometimes say y or f of x there. So that's the mathematical way, and this is here as sort of a, you know, a practical application of it, where we've just done it in simpler terms. But if you were using the trapezoidal rule in a mathematical situation, this is the one that you would write down. It was formerly on the formula sheet, but it's not on the current formula sheet, which would tend to suggest that you know, perhaps it's you don't need to remember it, certainly, and it possibly may not be examined. But, you know, take that advice at your own risk. Okay, now, Simpson's rule. Oh, it's a bit more difficult. Now, the trapezoidal rule was based on the area of a trapezium, obviously, because that's why I, you know, blathered on a little bit about the trapezium and whatever. However, Simpson's rule is based on the definite integral, is based on the a quadrilateral, a curve joining the ends by a curve rather than a straight line. So it's considered to be a little bit more accurate. And here it is written in the mathematical terms here, for f of x, or a function of x continuous on the interval a, b. So yeah, integral from b to a. So we put the highest value, or the value most on the right hand side, on the left hand side, and then we yeah, b and a, and then we take h over 3. H is still the same as previous, so you can work that out. It's b minus a over n, and then we go f of 0 there, and 1, 2, 3 through to f of n. And it goes in this pattern: 4 times the odd values, f1, f3, which is n, 1, 3, and so on, and 2 times the even, where n is 2, remembering that n starts at 0. Most important. So this is considered more accurate than the trapezoidal rule, as I think I've said. And instead of straight lines, it goes with parabolic arcs. So in this one here, for Simpson's rule, you need an odd number of ordinates. So that's 0 through 8. That gives you an odd number of those, and an even number of strips. And you'll see there's 3, 6, 8 strips there to work that one out. So yeah, that's sort of the theory, I guess. So next up is let's do a mathematical one, and approximate the area under the curve y equals negative x squared plus 100 between 1 and 7, using the trapezoidal rule, and b using Simpson's rule. So we're going to do the trapezoidal rule first. I think that proved to be the easiest one. So yeah, let's draw the graph. We can, you know, always important so that we know what we're dealing with. And so we know it's negative x squared. It's an upside down x squared. We know that it's yeah, that there's where it is, negative x squared. Now the 100, we can we know that the intercepts will be negative 10 and 10, because negative x squared, we could put that over where it equals 0, and negative x squared equals 100. Square root of x plus or minus 10, it would give us the two intercepts. And of course, the 100 tells us the y-intercept as well. So yeah, pretty easy to draw the graph. And then what's the actual region? Well, we just want the area between 1 and 7. 1 and 7. Alrighty, so there's the trapezoidal rule there. And so let's have a look at H is B minus A, which in this case here, if we should write it out. Oh, there it is. We've written it out. And it's 7 and 1. So 7 minus 1 is 6. And N is 6. Now you can remember that N starts at 0. So I'll just show you this. There's where we've calculated H. Is it H? Yes, H. And 6. N equals 6. You can see that from this little table here. You can see N equals 6 on the bottom there. So because N starts at 0, and we're going from 1 to 7. So there's 1, 2, 3, 4, 5, 6. There's 7 ordinates, but N is 6. So there we go. We just fill in that. So H is 1, and so we just get the half, and then away we go. We go Y0, which is 99, Y1, 51, and so on. So it's 99 plus, sorry, that's f of 7 there is 51, so the first and the last, and then 2 times the ones in the middle, 96, 91, 84, 75, 64, and yeah, there we go. Work all that out. That's half 150 plus 2 times 140, 485 square units. I've put square units there to be sure. It's not absolutely necessary where we're using the definite integral. Oh, yes, it is in this case here because we've been asked to find the area. So it must be in square meters because area is referenced in the question there. So that's most important. But if it's not, if it's just find the area under the curve and it just referenced as a definite integral, it's not necessary to show the area. But to be sure, show the area, I guess. You won't get any extra marks for it, but you won't get any taken off, and you'll know that you've got it covered if it was supposed to be shown. So yeah, a bit of a bob each way, as they say. All right, so let's now we want to do the same thing using Simpson's rule. So same graph, same deal there. There's Simpson's rule. Here it is, written out exactly the same between 1 and 7, but using Simpson's rule there. And H is still the same, worked out there. B minus A over in the same table, but just the values just rearranged differently and various things. I've written it out the long way, so it's the 4 2 4 2 4 2 sort of pattern that's being followed. But yeah, it's all well and good. And there we go. Work it out, and we get 486 square units. 1/3 of 1458, 486. So I'm just popping back up, I guess. I don't know whether we can do. I don't think we can go back in the recording stakes, but yeah, we'll go backwards. We see we went 485, I think, or something like that. So what now? Well, we could actually work it out using calculus, and this is where we can actually work out the definite integral there. By what we have to do is anti-differentiate or integrate what we've got there, and as you can see, I've got it equal to negative x cubed over 3 plus 100x plus k between 7 and 1. And so we just work that out. We put 7 into the formula, 7 cubed over 3 plus 700 there, as you can see, and then we minus the smaller one, which is 1 over 3 plus 100. The k gets cancelled out, so no need to worry about the k. She's all good. All right, so there's the numbers, and take it away, 486 square units, which is exactly the same as what we got with the with Simpson's Simpson's rule, which is these are, it's only approximating the area under the curve. This is the exact area by integrating. However, we do know that the Simpson's rule relies on a quadratic equation to join the ends of the various strips, and as it happens, this is a quadratic equation that we're approximating. So that would be why it approximates it exactly, which is handy and reassuring. All right, so with this newfound knowledge, let's move on to another one, and this is the area under the curve of y equals square root of x between 0 and 4. Same question. Using the trapezoidal rule, we've been asked for the area, so we need to show the units. The formula is the same as previous. Here it is written out mathematically between 4 and 0. As you can see, in this case here, you're going to have 0, 1, 2, 3, 4. So n is going to be 4. It starts at 0. So let's work it out. H is 1, and here's our little table that we get 0, 1, 2, 3, 4. As we can see, n is 4. So, putting the numbers, let's see the numbers. There we can see it all there. The first one is 0, last one is 2, and then 2, and then the ones in the middle, 1 plus 1.4 plus 1.73. Work all that out and you get 5.14 square units. 5.14. So we need to remember that, because now we're going to do it with Simpson's rule. Here it is. State the rule. Find it there. So this is from a previous formula sheet there. So state the rule so people know exactly what you're doing. Write it out mathematically between the definite integral between 4 and 0 square root of x equals approximately equal. That's what the wavy line means there. And there we've got it. Now put our little calculation for h, and yep, there's our table. So it's all written in there, just a matter of filling it in. The first is 0, the last is 2, and then it's 4 times the second one, plus 2 times the third one, plus 4 times the third, 4 times the third one. Yeah, sort of. I think I've got it. How it goes. So let's go then. So it's 0. That comes from here. Okay, 4 times 1. That's the one there. 2 times 1.41 is there, and 4 times 1.73 plus 2 at the end. That's how it all works out. And working that out, we get 5.25 square units. So slightly higher, 5.14, I think previously. And now we can work that out, mathematically using an infinite number of strips. That's what we've got here. So we integrate x to the half, or the square root of x, and that integrates to 2x to the power of 3 over 2, all divided by 3 plus k. So, yep, and then we differentiate that back the other way to make sure that we end up at x to the half. So, integrating x increases by 1 power, and differentiating x decreases by 1 power. All right, and so that equals 2 to the power of 8 over 3. Or there, the 0, well, nothing, the 0 will be 0. So all we need to do is work out the 4, the value when x is 4. And it's 2 to the 8 over 3, which equals 5.33 square units. So slightly more again. So, yeah, the second approximation using Simpson's wasn't too bad, but it was 0.08 square units away from the mean. And that's it for now. If you have any queries, let me know in the comments below the video or contact me, maurieio@maurieio.com. And, well, good luck.